So today we will learn how to use a scatter plot. And a scatter plot is basically a plot of numbers that are scattered. So like when I plot a point, that's where you put a point on the graph. So a scatter plot would be a bunch of points scattered. So for example, if you're plotting points, you might have one there, you might have one there, one there, one there. That's what we call a scatter plot. Now, where you put your exact points doesn't really matter. But in general, if you're starting from the origin and you're going this way, so we would call this a positive correlation. And the line I just drew, that's called the line of best fit. And there's a whole bunch of math that goes into finding that line. As you can see from my line, mine was just a pure guess, just for the notes. But in general speaking, and there's a lot of statistics and stuff to go into this that you'll learn later, but speaking in generic terms, you want about the same number of points on both sides of the line. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. For now, that's probably enough explanation. And I'm going to show you how to get that line from the graphing calculator today. Okay, but that's what we would call a positive correlation. No correlation. The data doesn't seem to be related. For example, if I plot how tall you are versus how smart you are, probably, we know it's true, but probably the taller you are, not the smarter you are, right? Probably has nothing to do with each other, right? So maybe this is the taller you are, the bigger size shoe you wear. I'm sure that has a positive correlation. But saying the taller you are, the smarter you are, intelligence is not based off size. Okay. And then negative. That would be when you start up here and in general words, in general terms, you fall down, okay? We would call this a negative correlation. We're going to draw a line of best fit. Line of best fit just means it goes through most of the data. Doesn't have to be exact. So the taller you are, I would say that's negatively correlated to the amount of clothes you'll find in a store that'll fit you. Okay, when I go to the store, a lot of the clothes don't fit me. That's a negative correlation. Anyone else can think of something that as you get taller, something else decreases? Your shoes increase, and generally, not always, but mostly. Those are hard to think of. So we talked about a positive correlation, no correlation, negative correlation, and you should be able to look at data and identify which one. Next, I have a table, and days into a semester, this kid started the semester and had 0 missing assignments. That's what it says, missing assignments. That makes sense. When you start a class, you don't expect to already have stuff due. Now I went to Sumner and we had homework over the summer, like books to read and stuff, and that's different. But when you start a class, you expect to have no missing assignments. After one day, the teacher assigned homework, and the kid already had 4 missing assignments. That's pretty impressive that the teacher assigned 4 assignments, at the very least. Okay? And this isn't how many assignments were assigned, it's how many assignments are missing. Okay? And after 2 days, the kid was missing 12. 3 days, missing 18. 4 days, missing 31. 5 days, missing 36. 6 days, missing 44. In general, the amount of days increases, so does the number of missing assignments. Say that it's probably going to look like this, and it's going to have a positive correlation. And then, notice, you only had 23 missing assignments after 7 days. So that's probably the end of the quarter where a kid tries to throw everything in your box. Please don't do that to me. I don't take that kind of stuff. Okay? You better do it now. So anyway, in order to get a better feel of this data, usually on the X you plot days. So I'm going to plot days down here. And we'll let this be 0, since that's what our thing starts with. 1, 2, 3, 4, 5, 6, 7. Okay, we'll call this days. And it's important to label your graph. Yes, thank you. Okay. Now the other one is number of assignments. I'll go ahead and put missing. And I need my number of missing assignments to go from 0 to at least 44. So I'm not going to count by ones. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I counted by 5s, that'd get me up to 60. I'm going to count by 5s. Notice the highest it gets is 44, so that should work. Except when you're plotting points, you're going to be doing something called predicting. So you want to give yourselves at least some space to predict. Who knows, maybe I should have counted by 10s, but we'll just stick with 5s. Let's go ahead and finish days. I don't know about these days, but we could go ahead and label them. Alright, from there, this is going to be our X. This is going to be our Y. We usually do days, seconds, time is our X, and the other one is our Y. So I'm going to plot 0, 0, 1, 4. I'm going to estimate that 4 would be about right there. Do not have to be exact for me. 2, 12. 12 and a half would be halfway through, so almost half. 3, 18. 4, 31. 5, 36. 6, 44. And 7, 23. So I can see that this has a positive correlation. In general, if I were to draw a line, it would probably look something like this. We have this data value down here that doesn't really go with the rest because obviously the kid decided to get some work done. But I'm guessing most kids, you know, they get into a bad habit, and I'm guessing, unfortunately, that even though this kid turned in work, people tend to do the same behaviors that they did before, so I bet they'll start missing assignments again, or she. So what we're going to do is we're going to create something called a line of best fit. We're going to write the equation for the line of best fit, and then we're going to use that line to predict, because all we have is up to 7 days, based off his trend, how many missing assignments will we have after 10 days. So to do that, I'm going to use a calculator. So if you need a calculator, go ahead and grab one. Everyone have one? Now there is a way on your calculator to get a line of best fit, but I'm not going to go into that much detail. I just want you to kind of guess. It looks to me, well, actually we'll do this. I got a better idea. What we're going to do, we're going to go to our calculator, and we need to turn something on. And I always forget where that button is. There's a catalog button on here somewhere. Do you see it? It says catalog. Thank you, 0. See, if you look enough, there's lots and lots of functions. So on the 0, there's a catalog button. If you hit yellow to get to catalog, and then I want you to turn, just go down to D. Look at all the things your calculator can do. Heck, I bet there's things in here I don't even know. And if you were to do some research, but what I want to do is I want to turn diagnostic on. And the reason why I want to turn diagnostic on is because that will tell me a correlation coefficient, and we'll talk about what that means here in a second. So to turn it on, just hit enter, and then enter again, and it'll be turning on diagnostic. So I did second to the catalog, down to the D's. And I hit enter, diagnostic on, enter to run the function, and now that's on. Once you have it on, it'll stay on until someone turns it off. Okay. Now, we're going to go and we're going to hit stat, statistics. So stat right there. We're going to go to edit. In your list, you have an L1 list. Think of that as your X. And then your L2 list, think of that as your Y. Now mine already has data in it. You can either go through and hit delete on all of them, Or if you go to the top and you hit clear, down arrow, it'll just clear out the whole thing in the list. Okay, so your choice, you want to go and delete individually, delete, or do you want to go to the top, hit clear, down arrow, that will clear everything down the list. So L1 is our X, so we're going to put in our days, that is 0, 1, 2, 3, 4, 5, 6, 7. Go ahead and do that, 0 through 7. And then for our missing assignments will be our Y, our L2. We'll put in our 0, our 4, our 12, 18, 31, 36, 44, 23. And it's not a bad idea to look at the data one more time and just make sure you typed in 0, 0, 1, 4, 2, 12, 3, 18, 4, 31, 5, 36, 6, 44, 7, 23. Now there are many things that could go wrong on this screen, and that is if yours does not say L1, L2. Does anyone's not say L1? Yours? What does yours say? Let me see your calculator. Okay. So for you, you're on the wrong screen. We are under Stat and then Edit. And you do have an L1, L2. Okay. So you need to put that in L1, L2. Anyone else have any troubles? You do? Same thing. We're in the right screen. Okay. Okay, you should be under Stat, Edit, you put in the data values. Now what we're going to do is we're going to do a calculation. And we call this the line of best fit. A line is in the form y equals mx plus b. So, not every regression or scatter plot is linear. Some are more of a quadratic path. For what we're doing today, we're just going to assume that it's linear. Okay. So after you put the data in, you go Stat. We're going to do a calculation. So I hit Stat, Calc. And there's all kinds of calculations you can do on the screen. One variable statistics, that's really nice if you want like mean, median, mode, quartiles. That's a good way to get that. Other ones I know, if you wanted to make a regression line that's quadratic, there's even cubic or quartic. But for our class, we're going to stick with linear. And if you ever take statistics, you'll get to do the rest. Okay. So you're going to hit Enter. And this is going to run the linear regression. Okay. So hit Enter again, and it's going to tell you the equation of a line. It says y equals ax plus b. Think of the a as an m. So this is 5.3. Let's do 2 decimals after, 5.31. And then the y-intercept is about 2.42. Okay. If you wanted to be completely exact, you would write down the whole decimal. For this class, just write down the 2 numbers after the decimal. That should be enough. So the equation is y equals 5.31x plus 2.42. So here is my slope, here is my y-intercept. And then let's go ahead and talk about the R value. We're not going to plot the R value. All the R value tells you is how strong the correlation is. The closer it is to 1, the stronger it is. The closer it is to 0, the less strong it is. So 0.84, 84%, right, out of 100, that's a pretty good correlation. So linear works great. It looks like all your calculator is saying with this is that this path appears to be pretty linear, and it does, okay? And I bet if we took this point, it would be almost closer to 100.